All right, good. I have started the recording for tonight's meeting. First, let me share the screen with you. Okay. All right. So I'm now sharing my screen with you for tonight's meeting, and now we shall get into the material for this lesson. I mean, for this module. Okay. All right. Today we will get into module 2, which covers the probability theory and the Bayes theorem. Okay. What I will do is I will approach the material in a backward way, which means I will cover the assignments first, because I'm afraid that our time may run out before we could cover as much as material as we can. Okay, so what I will do is to get into the course assignment first. All right, let me see. Okay, if you open the course assignment, you will see that we will cover exercise 2.2 for question A, 16, and 19. Of course, don't get me wrong, not just that you are limited to work on these questions only, but that it's for the sake of your time and so forth, I did not impose a heavy workload on you. All right. And actually, I did not assign assignments for 2.5, 6, and so forth, and only 3 questions for each section. So that is very doable, not weightlifting for you. All right. Okay. So let's get into these questions, A, 16, and 19. And then I'll cover them as if we are giving lectures while giving you some hints and tips for these questions, solving these questions. Meanwhile, that being said, in the assignment section, I also give some hints here for you. For example, when we come to section 2.3, you will see I give you the hints that you can refer to example 2.3.7 in page 68 and refer to this website for the distributions that's used to solve for this question, which is called hypergeometric. We will cover in a little bit. And then we will cover apply Bayes rules and refer to example in here. Okay. All right. Okay, let's get started to 2.2.8 on the module. All right, in the module we will see module 2. We see let's look at the question. When you click on the probability theory, you will see the question 2.2. What's that? 2.2. Not this one. 2.2.8. It takes a little bit to download. 1 second. All right, 2.2.8. In a city of 65%, the people Let me show me. In a city, 65% of all people drink coffee, 50% drink tea, and 25% each of both. What is the probability that a person chosen at random will drink at least one of coffee or tea? This question is quite straightforward. That is, you will answer the what? You will answer the union of the two events. Okay, the union of two events. If I can write on the screen here, maybe, yeah, maybe I can. Which is, look, if I, all right. So the two event probability, T, coffee, right? Coffee, 0.65. Probability for T, 0.5. Probability for tea and coffee, 0.25. So you want coffee and tea, and this is coffee and tea both. Coffee and tea. So you want to know at least one that include what? At least one. So these areas. So obviously you know what to do, because if you add these two together, right, the intersection area will be counted twice. So how do you calculate these shaded area without counting the intersection area twice? The answer will be very obvious. Okay, so you know how to do it that way. Let me save this one. Module 2. 1 second. Okay, 2.2.8. Okay, hints. All right. That's our 2.2.8 question. All right. 16.
Professor,
okay.
I have a question there.
Yes. Say it again.
Right. So do you expect us to use R program here?
No, that's too easy to use R. I mean, not necessary. Not necessary.
Right,
Yeah, we will see that down the road, but not sometime. R is too powerful for it, or not necessary. Yeah.
Got it. Thanks.
Yeah, no problem. Okay, we are covering some basic concepts, probability. So what you need to use is actually Excel. Okay, and some statistical thinking, and for probability concept, as it might be abstract. When we get to Bayes rule, you will see. Not that hard, but you need to use a little bit statistical thinking. Okay. All right. So for this one, for this 2 to 16, well, let me 1 second. The question actually goes down here. 216. All right. Let me see. Yeah, how do I? It goes to 2 pages. Anyway, okay. Okay, no problem. All right, so for solving for this question, you are to find that probability, but so probability A union A or B, that's or. A or B means A. This part is A and B. A and this is and. But this whole thing, the shaded area, is A or B. Okay. So now that you have A and B, what you need to know is A and B, and subtract it from APA plus PB will be the answer. And but how do you find a PA and PB? You have to read a question. Let me see what's the question here. Well, PA and PB. Oh, okay. It doesn't have to do with the table, so you just ignore the table. They are mutually exclusive event, so that answers the question. If they are mutually exclusive, that means what? PA and PB is what? 0. They don't have that intersection. That part is empty set. Okay, and the probability is therefore 0. So so that's easy. So that PA and PB is just PA plus PB. And because PA and plus PB minus PA and PB, I mean probability of A and B is empty. So the answer is obvious. And then AC is the complement set of PA. So you just do 1 minus P probability of A. Then PAC union PBC, that means what? That means that's equivalent to A and B, but actually I should write this complement. Okay. Why? Because look, PA and B, the complement set of A and B is, suppose this is actually this is A and B. A and B is empty set. So everything A and B have nothing in here. So complement set is everything. Everything other than the empty set is everything. Okay, and so in this case, then you know what? You know A and B, but A and B is empty set, which is 0. So that's what? That's 1 minus 0. That's 1. The answer is 1. So it's obvious. So on and so forth. I think you can easily find with we call this Venn diagram. With the Venn diagram, you draw the Venn diagram, you should be able to answer these questions. Okay. This is a second question. And you can see actually the D and the C are actually the same. Okay. The same. And I'll leave the E for you to work it out. Okay, 19. All right, for question 19, you refer to table 222 and then define the following events. A is a person chosen in from the city. B is a person disapproves tax increase. Okay, so from tables 2.2.22, you see the survey results of the text increase. The person, the C is what? 2.19, and you see that C is live in the city. So for people who live in the city, like 150 out 150 out of what? 150 plus 250 is what? 400. So out of 400 people who live in the city, some of them approve the tax increase, but most of them, that's 2050 over 400%, right? Over 400, that's about 62.5% say no to the tax increase. So depending on where they live, they may be for or against the tax increase. Okay. Now, what the question is asking you is what's the probability of B? B is a person chosen is from the city. A is person chosen from the city. B is person disapproved tax increase. So what's the probability of B? That's obvious. Person disapprove, say no. So what you do is you can plug this number, repeat this number in an Excel spreadsheet, and then do what? Sum up the numbers to the, you add one more column, and to count how many people are there in total. Count how many people are there in total. Okay. Okay, so this is like 400, and this is like also 400, and it's 200. So altogether is what? 1,000, right? And so these, the sum of them over 1,000 will be probably the probability of B, right? And so forth. I think A, and then you can calculate A. A complement is what? Chosen. A is from the city. So A complement means from suburb and rural area. So if they are from suburban or rural area, and they are also against the tax increase, so that means what? Sorry, they are from here and they are against. So the probability, this should be end. So this area, all right. So that means what? It means you take the sum of it and divide by the total number of it. That's the probability. So on and so forth. Okay, I think that's good enough for this question. Now, so that's about basic probability. So, and you should know that through this way of handling it, we are actually calculating what? Relative frequency. Relative frequency is the foundation of most basic form of probability. Relative frequency is also percentage and also proportion. All these stands for probability in its most basic form. All right. Okay. So that's some basic probability concepts. Now let's look at the 2.2 2.3 section. Okay, we are getting harder here. 6, number 6 is right here. By the way, you should refer to these examples yourself, as I refer to them as hints and tips for you. Okay, so if you look at this question, 2.3.6 is right here. Okay, this one is says how many different 6th place license plate, okay, are possible if the first 3 places of and the last plate are to be occupied by letters, and the 4th and the 5th places are to be occupied by numbers. So if you to answer this question, then you there are what, 6 numbers. You have okay, there are 6 numbers, 6 place. One, two, three, four, five, 6. Okay, and if the first 3 are letter and last are by letters, right? By letters. So you have 26, 26, 26, 26. And 4th and 5th are numbers. They're 10. So now you know how to do it. You multiply them together. All these numbers together will be your answer. Yeah, that's easy. And 12. Okay, number 12 has to do with the distribution called hypergeometric distribution. Hypergeometric. I call it hypergeometric. So what this says is a package of 15 apples contain 2 defective apples. So you can split the 15 to 2 groups. Okay. All right. So here's an urn. You have 15 apples. 15 apples, but 2 are defective. Let's say these are defective, bad apples. So out of the 15, there are 2 bad apples, and you pick 4. You take a sample of 4. Let's say the capital N stands for how many in them, and K stands for bad apples, and you choose whatever it is to see how many are defective. This type of question is a hypergeometric question. Okay, so the probability, so A means probability that none is defective. So X is number of defective apples. So X is 0, that's the answer. The probability none of them is defective. Out of 4, X is 0. That's what it means. So to answer this type of question, you will do this. The combination that out of 15 you choose 4. how many out of the 13 which are good? Okay, since you have 0 bad out of 4, that means all 4 must be good. So you have 13 good, you take 4 out of them. But then you multiply this by the combination that you have 4, you choose what? 0 out of 4. All right. Sometimes you use C, or sometimes you use, for example, 13, 4, that's equivalent to 13, 4. Okay. Either way, it will be fine. If you refer to the textbook, you will see the different notation, but they are the same. All right. Okay, so so this is the answer, and the second one, at least one of the selected is defective. At least one is defective. That means what? There are two ways to calculate this answer. It means at least one. So you have probability x equal to 1. Can there be 2? Yes. Plus. Sorry, plus. Can there be 3? Yes. Can there be 4? Yes. So you have to calculate this. You plug in this formula 4 times. That means okay. So you, for example, for the first one is 13 choose 3 good times 4 choose 1 bad over the same thing, plus 13 choose 2 good, C 4 choose 2 good over the same thing, plus 13 choose 1 good and times C 4 choose 3 bad over the same thing, plus 13 choose 0 good, C 4 4 by the same thing. So you can do that, but that's kind of cumbersome. So what you should do is actually just what? 1 minus x0. So when you get the answer for the first question, just do it 1 minus that. You will get the answer to the second question. Okay? Yeah. So that is 2, 3, 12. 2, 3, 12. Is there an easier way? Yes. Use the website I show, or maybe hypergeometric distribution applet. Of course, you can use Excel, you can use R, but we try to use the easiest, the most handy tools for it. Okay, for this one, this is a hypergeometric distribution. Okay, N stands for sample size. How many of them are there? 4. Capital N stands for the population size. How many of them? 15. They use different notation. Capital M is what? Which is K. Capital M is actually K. That means 2. That means we have 4 bad apples. No, 2. Wait a minute. Oh, sorry. Our meeting will end in 10 minutes. Okay, stay with 3. Okay, sorry. What I wrote this wrong. This is 2. This is 2. Okay. This is 2. So what I wrote this wrong because 13 plus 2 equal to 15. So obviously you can have what? you can have 3 bad apples. Impossible, because there's not so many bad apples in there. Okay, so that is impossible. All right. Okay. Yeah. Okay. So that's I have to revise this. Okay. And so you plug in x equal to 0, x2 equal to 0, and or leave it blank. You will see all the answers right there. Okay. I will let you try and move your cursor to it. You'll see 1, 2, 3 probability. Okay, you can do both and then double check the results yourself. I post this website there for you already. Okay, that's a shortcut. 2, 3, 12, 12, and then what? 19, 15. Okay, example 2, 3, 5. I will let you think about this question. Okay, this one is more interesting and although a little bit challenging. I will give you a hint that you use the Excel to find the interpolation when it hits 0. Okay, I'll leave it. I'll let you think about this question. Okay, and then I can give you more hints down the road. This is a quite interesting question. You may think a little bit. Okay, 15. And now 2.4. 2.4 is on Bayesian. Okay, so let me try my best to. If we got cut off in 10 minutes, we will finish in time. Okay, 2, 4, 14. 2, 4, 14. All right. Okay, this question. And use 242. Okay, obviously use this 242. So with this, if you understand this question, you will understand the other question. So what this question asks you is that what is the probability? Okay, find given X-ray, find TB. Okay, given X-ray, find TB. Okay, so probability giving positive X-ray, find TB. Okay, so this is what? Given this, find TB. So that means out of so many tuberculosis patients, what is the probability? I mean, sorry, given so many positive X-ray results, how many of them actually have tuberculosis? I mean, without tuberculosis. Oh, sorry. Not here. Here. Because with tuberculosis. Okay. So that is what? That's 27 over 97. That's the result. Easy. So if I say, what's the probability that it is a negative X-ray given is without TB? Then easily you can see this is without TB. Out of them, that many has negative. So A1A, A3, over 1945. Okay, so this is the easiest way to get the answer. Now, we need to move on to the base rule to 424. Okay, so for this question, I hope that we can finish this in time before we get cut off. Excuse me. Okay, the quality control chart of certain manufacturing shows that. Okay, so to do this, you will do this. Draw a tree diagram. Okay, 45% distributed defective parts produced in the company are due to mechanical error. So due to mechanical error, 45%. Due to human error, 55%. Together is 100%. Okay, that's easy. But out of the defective part caused by the mechanical error, okay, so given mechanical error, given, this is given, conditional, and it has defective, the error is what? 0.95. So obviously, given mechanical error, and there's no error, complement, no error, 0.05. The same way you can also draw a graph. Probability that due to a human error, you have a human problem, you have error is what? 0.8. So E complement due to human is 0.2. Then what shall you do? You shall, based on this, you can find the probability of error and M, which is probability of M times and M times the probability of E and M, given M. Okay, based on the conditional probability formula, which you should refer to in the text. Then also probability of E given, oh, what happened? Hello? Do we got cut off? Not yet. Okay, probability error due to human is probability of human times probability human and then error. So you have these numbers, so that means this times that, and then this times that will give you these two error. But the total error is what? Is probability E and M plus probability E and H. So after you calculate them separately and add them up, you get a PE. Then you come back to find the answer. Suppose that the defective part was detected in inspection. What is the probability that defective is due to a human error? So given you have a defective part, so the question A means given you have the error, how much is from human? So this is what? Probability H and E, probability E. You already get the probability E from here.